Evening everyone, welcome to another video of the tryhackme Advent of Cyber, Day 8 Smart Contracts. I did already go through this and film it, but the OBS was actually pointing at a different screen, so it ended up just being a voiceover rather than a walkthrough of this particular task. So we're going to run through it again. So it does show at the bottom that the tasks will be completed because they have, but just going to run through that again today for you. So this one is introducing us to the blockchain, smart contracts, and just explain a little bit of how it all works, how the smart contracts relate to the blockchain, why that's important, how the contracts are related and what they are built upon, and the standard core functions of it, and then shows us a way to understand and exploit a common smart contract vulnerability. So let's crack on with it. As always, make sure you read through this, make your own notes, go back, cover research around the topic. Don't just go of what's in here. This is just an introduction, so make sure that you're going around, you're gaining your own knowledge, and finding out additional information alongside this bit here. As always guys, please hit like, subscribe to the channel, hit the notification bell so you get updates of when the latest videos go through, but really do appreciate hitting that like button, subscribing to the channel, showing your support. Let us know that the content that we're supplying is of interest and helping you. So the blockchain, as always, I'm not going to read through every bit in detail. Again, this is just an introduction, an idea to show you how this particular task is achieved, and just to cover the basics in it to allow you to progress further and make your own research and develop your own knowledge on this. So fundamentally, what is a blockchain? A blockchain is a digital database or ledger distributed among nodes of a peer-to-peer network. The blockchain is distributed among peers or members with no central servers, hence it's decentralized. So basically there isn't one central point or one central server that everything relates to. This is a peer-to-peer network. So again, it doesn't focus on one core server that if that gets taken down, it doesn't affect everything. Alright, there are multiple nodes and servers to this that or peers. Now it's crucial that all those peers maintaining integrity of the blockchain, because if one member of the network attempted to modify a blockchain maliciously, other members would compare it to their blockchain for integrity and determine if the whole network should express that change. Alright, so again, as it says, the core blockchain technology aims to be decentralized and maintain integrity. Smart contracts. Smart contracts are very comparable to any other program created from a scripting language, and they're most commonly used as the backbone of decentralized finance applications, so to support a cryptocurrency on the blockchain. They generally facilitate the currency exchange between entities. A smart contract defines the details of the exchange. A smart contract is a program stored on a blockchain that runs when predetermined conditions are met. So for example, looking at this little very basic one here, contract B wants to deposit 1 Ethereum. It then makes contact with contract A, says I wish to give you 1 Ethereum. Contract A says thank you very much, and then it's deposited. On this one here, again, contract B says I wish to make a withdrawal from contract A. So what contract B will check the total balance of contract A. Conditions are balance is not empty, so there's 1 in there, and then contract A will then supply the Ethereum back to contract B. Alright, so again, it's a very simple program, but that's in effect what it does. One program is going to another, asking a question, is this possible, yes or no, and then obviously it supplies the result, and a transaction either does or does not happen. So where are the vulnerabilities in the smart contracts? The vulnerabilities come from where it's very basic here, yes, balance is not empty, so contract B wants to withdraw from contract A, but at no point are we specifying, yes, the balance is not empty, but to what figure. Alright, and that's where the loopholes can start to come, because we haven't designated a figure of what's available to either withdraw or available to send across. Alright, so one of the most popular attacks is the re-entrancy attack. As you can see here, basically this breaks it down. This little diagram shows what it is. So again, touching on what we just said, the attack function require a value greater than or equal to 1, deposit 1 ether, withdraw all ether from account balance. So with the withdraw function requires balance greater than 0, send the account balance to the contract that requested a withdrawal, set the account balance to 0. So the difference is between the account balance and total balance in the above diagram, the storage contract separates balances per account and keeps each account's total balance combined. Alright, so again, here it just breaks it all down, shows you what introduces you to the re-entrancy attack. So again, get your understanding here, go onto Google, find additional research in this to really develop your knowledge down in this particular subject. So moving on to the tasks in the room. For this task, we're going to use a program called Remix IDE. So I'm just going to open it up in a new tab. We're also going to need to download the zip folder attached to this task. So if you go up to the very top, download task files, hit that, download the files. They'll go to whichever folder is set for your downloads to go to. Normally that is just the downloads folder, or Mac or PC or Linux. Obviously you may have changed it, but that's where that will get downloaded to. Now within there are two files which we're going to use both. One gathered from the best festival company used to host their cryptocurrency balance, and another one is a malicious contract that will attempt to exploit the re-entrancy vulnerability. Alright, both contracts are legitimate Solidity contracts, but no need to worry if you need help understanding the program syntax between each. Alright, so let's open the program up. Let me just quickly remove those because obviously they're already in there. So this here, just clear the cache and refresh the page. So this here is our dashboard for Remix IDE. See here, this is our file explorer. So again, where all of our files go, we can add stuff into it just in this section here. So again, this is where we can open our files. Down the left, search facility, the compiler, the deploy and run transactions, the debugger, the analysis, and the testing. Okay, so first things first, we're going to open the files up that we need. Downloads in there they both are, and there they are both in there. So the first thing we're going to do is we're going to compile them. So easiest way, click on one, hit the plus sign up there, that will then start to compile it. Oh, my bad. The first thing we need to do is compiler. We need to change that to 0.8.10. Okay, so you'll now see that that's now starting to compile. Once that's done, you can see the little spinners there. Alright, we'll let that go through and we could then go back through and select it for the attack one. Okay, so we've imported the contracts into there, we've changed it to 0.8.10, so now we're looking to, from the drop down compiler menu, now you can compile the contracts. So that's all we're going to look to do now. Let's just refresh it now I've updated it. So where I've done it all through, it's thrown me a little, so now we're on there. Good. Right, so let's get an ether store, hit compile, should hopefully pop up here. There we are, compiled. There's our bits and pieces there. Let's come back to this one, let's compile the attack. Again, I find it easiest just to hit the play sign, Control and S does the same job. So they're now both compiled. Alright, so now we can select the contract for deployment. So if we come down to our deployment one here, okay, we've got our account that we're using up here. We'll run with the Ether store here. Okay, we're just going to hit deploy, and that deploys our contract. We've got the green tick. So now down in this section, we've got our deployed contract bits and pieces. So if we change this to 10, the value of what we're doing, change that to Ethereum, and then we hit deposit. Boom. You'll see now, okay, our balance has increased to 10. Alright, down here we've got full debug that allows us to show everything that we've got going on. Alright, and then down in this window, a full breakdown of our transaction hash, which we can copy from where to where. Okay, and all the other little bits and pieces that we need. So that there is how you deploy your contracts and make your deposits. Okay, so what we're going to do now, we're just going to remove that from our list. We're going to come and we're going to make select our new account, select our string there. We're going to deploy that again. Okay, this time now what we're going to look to do is we're going to copy that. I did notice that, where's our compiler gone up here? For Ethereum, that hasn't compiled properly. Okay, there we are. Now that's in there. So where we've just deployed this one here, we're now going to come down and we're going to copy this, because when we go to attack it, we need to supply it with an address. So we're just going to copy this bit, we're going to put that in there. Now we're going to hit the deploy, because that's now telling us to attack that contract. So now when we hit deploy, you'll see at the bottom here, we've now got attack. Alright, we've also now got this little bit of information that comes in here. So now that we've got our contract in place, alright, nothing's happened. So now this is where we need to start mixing the values up of what we're going to do. So for example, we want to go 100 Ethereum, or if we wanted to go to 50, we'd hit 50, bam, hit attack. Alright, and there we have a flag that's popped up. Chances are we're going to need that, but we have now successfully just attacked that contract. So if we break through here, select the contract you want to deploy. We did that. Deploy the contract by pressing the deploy button. You now need to provide a reference to the contract you are targeting. So this bit here, providing the reference, if we go back, was when we copied this one here. So we deployed it, we then copied the name, and then we placed it into that box up there and hit deploy. Okay, confirm the contract is deployed, and attack the function can be seen from the deployed contract subsection. That we can see it's there. Execute and or interact with the contracts function. Note that most functions require some form of value input to execute them properly. And that's where we attack with a 50, and bam, we've now got our flag. So as we've done, we've completed that first one. What flag is found after attacking the provided Ether store contract? And there is our flag. Okay, so we deployed the main contract first, then we've then set up the attack contract to the deployed contract, and now we're through. And that, guys, is room 8. Alright, again, great introduction to the blockchain, what's involved. If you found it useful, please hit the like button, please subscribe to the channel, turn the notification bell on so you can keep up to date with the rest of the advent of cyber security challenges from tryhackme. Good luck with that. As always, happy hacking, and we'll see you in the next video.